Good morning, sir. My name is Srinath Kumar. I am from ECE B section and my roll number is 23401A04B3. Today's my topic is analog non-inverting amplifier and my subject is analog and digital IC applications. Non-inverting amplifier. Introduction to non-inverting amplifier. A non-inverting amplifier is a type of operational amplifier configuration where the input is applied to the non-inverting input terminal. It provides a voltage gain that is greater than or equals to this configuration is widely equals to 1. This configuration is widely used to signal applications due to its high input impedance and stability. Non-inverting amplifier. It is, and the block diagram is shown in the PPT slide. Basic concept of amplification. Amplification involves increasing the amplitude of signal while maintaining its waveforms. Operational amplifiers are commonly used components for signal application in electronic circuits. The non-inverting configuration ensures the output signal in the phase with the input signal. Circuit diagram overview. The non-inverting amplifier circuits includes a operational amplifier, a feedback resistor, and an input resistor. The input signal is applied directly to the positive, that means non-inverting terminal of the operational amplifier. The feedback resistor connects the output back to the inverting terminal, controlling gain. This is the overview of the circuit diagram. Key components of the circuit and the circuit diagram is shown in this slide. Operational amplifier, the core component, provides high gain and linear operation. Resistors set the gain and feedback ratio of amplifier. Power supply powers the operational amplifier to amplify the input signal actively. Voltage gain formula. The voltage gain is denoted by AB of non-inverting amplifier is given by 1 plus RF by Rin. RF is the feedback resistor connected between the output and the inverting input, and the Rin is the resistor connected between the non-inverting input and ground. How the gain is controlled. Adjusting RF and Rin changes the voltage gain of the amplifier. Increasing RF or decreasing Rin results in higher gain. Designing the circuits involves selecting resistor values to achieve desired applications. Non-inverting amplifier circuit. R2, R1, V in, V out. Input impedance characteristics. Non-inverting amplifier have very high input impedance, minimizing loading of the source. The high input impedance makes them suitable for sensor and signal conducting applications. Output impedance characteristics. The output impedance of the non-inverting amplifier is low, allowing it to drive loads effectively. A low output impedance helps maintain a stable output voltage across different loads. Advantages of non-inverting amplifier. High input impedance minimizes loading effects on the source, provides a stable and predictable gain with minimal distortion, easy to configure and adjust the gain by changing resistor values. Difference between non-inverting amplifier and non-inverting amplifier. It is the main difference is the way the input voltage is applied at point 3 or pin number 3 or 2. Limitations of non-inverting amplifier. The maximum gain is limited by the bandwidth and stability of the operational amplifier. They can be more sustainable to noise if not properly designed. Power consumption can be higher compared to the other amplifier configuration. Frequency response characteristics. Non-inverting amplifier have the bandwidth limited by the gain bandwidth product of the operational amplifier. Gain decreases as frequency increases beyond the certain point. Applications of the non-inverting amplifier. Used in the audio amplification where preserving phase is important. Sensor signal conditioning to boost weak signals for the further processing. Comparing with inverting amplifier. Inverting amplifier invert the phase of the input signal, unlike non-inverting amplifier. Inverting configuration generally have lower input impedance. Examples are calculation of gain. Given that RF is 100 and RN is 10 kilo ohms, the gain is 1 plus RF by RN. That means 100 by 10k plus 1. That equals to 11. This means output will be amplified 11 times the input voltage. Practical circuit implementation. Use a low noise of operational amplifier. Operational amplifier signal amplification. Keep feedback and input wiring short. Summary of key points. Non-inverting amplifier provide high input impedance and stable gain. Conclusion. Non-inverting amplifier are virtual components in the electronic circuit requiring reliable applications. Thank you.